Bit manipulation is a language feature that is underused by most developers. I'm going to go over what it is and how to make it easier to use. So bit manipulation is a language feature that allows you to store many Boolean values in one integer. So it's kind of like having a list of bools or a dictionary of bools or something like that, except with bit manipulation it's going to take less memory, and it's also going to perform faster for operations like modifying the collection of bools or searching to see if a particular bool is turned on or off. So those are the advantages of using bit manipulation. And the way that the computer does this is that each bit in an integer is like one Boolean value, right? It can be turned on or off to represent true or false. So the C# language and many other languages include these bitwise operators that allow you to turn individual bits on or off, or check to see if an individual bit is turned on or off. And a lot of developers find this syntax to be inconvenient. So it's not just the bitwise AND operator. You'll probably want to put this in parentheses, and then you need to check if the result is equal to 0. So that's a lot more to type than just, checking a dictionary index or seeing list.contains or something like that. So I've added some wrapper functions that allow you to use this language feature more easily, right? I've made it so you can do the same thing by just calling a function instead of having to type all this out. And before I continue farther, let me show you some examples of when you might use bit manipulation. So maybe you want to store all the different roles that a user could have, right? Are they a regular user, an admin, manager, or medical? These would be used to control which fields a user can see or edit. Another example might be if you have one field that has multiple validation errors, like let's say the user's creating their password and it needs to meet certain requirements. There's many different validation errors that could fail. Maybe you miss the minimum length, maybe you exceed the maximum length, maybe you don't include lowercase, uppercase, or symbols. Those are all the different validation errors. We have one enum to store all those possibilities. Now, notice that I've specified integer values for each of my enum values, and they are not just 1, 2, 3, 4. They actually double each time, 1, 2, 4, 8. In other words, these numbers are powers of 2. And the way that powers of 2 are stored in a binary format is that there's only one bit turned on in each int. So that's what allows us to store multiple Booleans in one int. So if this is going to give you faster performance, why don't most developers use it? Well, as I mentioned, the syntax is a little bit inconvenient, but also most developers don't understand the concept. So most developers aren't familiar with how binary numbers are stored, and some developers say that they don't understand the syntax. I'm not sure what there is to understand about syntax. I mean, you just look up the documentation and accept whatever it says, but a lot of developers claim they don't understand the syntax. So that's why I've written wrapper functions to solve all these problems with bit manipulation. So instead of having to type this out to see if the user has a particular role, or instead of having to type this out to give the user a particular role, I have these wrapper functions called setRole and getRole. So here's an example of using bit manipulation directly. I want to create a role, I want to set up a user to be both an admin and a manager. I use the bitwise OR operator on the values manager and admin, and the result of bitwise OR is an int where all of the bits in either value are set. So that value rolls over there would have the second and third bits turned on and everything else turned off. But if you're a developer who doesn't want to deal with this bitwise OR syntax, here's an easier way of doing it. So you could declare another role and start it off with roles.none. So that's set to 0, no bits turned on. Then you can call the setRole function, and you posit the original role and the role that you want to be set, the bit that you want to be turned on. And the return value is the modified role that has this bit turned on. So first I call setRole for admin, and then I call setRole for manager. And now if I want to check if that variable actually has those roles, I can call the function getRole and posit the variable I want to check and which role I want to see if it contains. So I check to see if the role has admin, manager, or medical, and I have an output message for each one. So how do these wrapper functions work? Well, here's setRole and getRole, and these each call a second layer of wrapper functions, setBit and getBit. And setBit and getBit can be used for any enum. So the main thing that these wrapper functions do is just costing the parameters and costing the return value in the case of set. Other than that, it's just calling setBit or getBit and running these lines that use the bitwise operators. So let's run the program and check the output. So the output we're expecting is that we're expecting to see this message and this message, but not this message. The reason why is because I only turned on the admin and manager bits, but not medical. So let's run the program and see the output. User has admin role, user has manager role. Great, that's exactly what we're expecting. Those are the roles that we set. So in summary, these wrapper functions allow you to use bit manipulation even if some of the developers on your team don't understand the concept, or they don't understand the syntax, or they find the syntax to be inconvenient. You can still get the performance and scalability benefits of bit manipulation without having to type the bitwise operators manually. Remember to like, comment, subscribe, and share. That's it for today. See you later.